Hello, everyone. In this video, I will introduce Agentic Scholar, an agentic scholarly data management system. With the rapid growth of scholarly data, researchers increasingly need systems that can query papers efficiently and effectively. Agentic Scholar is designed to support 3 tiers of scholarly queries. Tier 1 is paper retrieval, finding papers that match constraints on metadata, problems, methods, or data sets. Tier 2 is extraction and synthesis, extracting settings or results from one paper or comparing and synthesizing evidence across multiple papers. Tier 3 is discovery and generation, tasks such as research trend analysis, milestone paper selection, and research idea exploration. These scholarly queries have 4 characteristics. First, they are often open-ended and evolving. A user may start with a broad trend question and then move to comparison or idea exploration. Second, they require multi-step semantic reasoning, such as extraction, summarization. Third, they depend on multimodal evidence and synthesis because the answer may need to combine text, figures, and tables across papers. And fourth, high-level queries require context-aware knowledge generation. Based on these query characteristics, we identify 4 core challenges. The first is semantic representation. Scholarly documents have rich internal structure and cross-paper semantic links that must be preserved. The second is planning complex pipelines. Scholarly queries do not have fixed algebraic semantics like SQL. The third is generality and extensibility. Hard-coded query-specific pipelines are too brittle. And the fourth is interpretability and traceability. Researchers need to understand how answers are produced. Existing systems are fragmented and none supports all 3 query tiers end-to-end. Now let me move to the method, starting with the storage layer, or the knowledge representation layer. The key idea is to transform the scholarly corpus into a taxonomy-anchored knowledge graph. At the document level, the graph preserves fine-grained structure, including papers, sections, tables, datasets, baselines, and so on. Beyond that, Agentic Scholar also introduces problem and method taxonomies as first-class semantic nodes. This matters because many Tier 3 queries require reasoning at the topic level, not just over individual papers. The taxonomy is also designed to support progressive updates, so new papers can refine the structure without rebuilding everything from scratch. The second layer is the planning layer, which is an LLM-centric hybrid query planner. Given a scholarly query, the system first uses a query decomposer to identify the task and its scope. Then it follows one of 2 paths. If the task matches a common query type, Agentic Scholar uses predefined plan selection. It first performs candidate filtering using semantic search, and then applies LLM-based re-ranking and validation to select a reliable, reusable plan. If the query is more open-ended, the system invokes a dynamic plan generator. This generator first creates a high-level logical plan, then performs low-level operator instantiation, and finally runs validation and self-correction. So the planner combines the efficiency of reusable plans with the flexibility of dynamic generation. The third layer is the execution layer. Agentic Scholar represents the plan as an execution DAG and runs it using a parallel DAG executor. The system provides a defined operator set, including operators such as search, extract, summarize. This design is both general and composable. Different scholarly queries can be expressed by combining operators. The engine also supports result caching and intermediate reuse, which improves efficiency across repeated or overlapping queries. Finally, let us look at the results. Agentic Scholar achieves up to 43% better Tier 1 retrieval quality, up to 33% higher Tier 2 NDCG, and up to 54.7% better relevance for Tier 3 queries. These results show that the architecture works well across all 3 tiers, not just one isolated task.